First part today, reviewing. Write the slope-intercept form of the equation of a line. Okay, so we're trying to get this. So read the question, figure out what they want. Slope of 5. That's telling me the m. Here's an x, here's a y. So I'm just going to take and plug in there. The y, -3, the m is 5, the x is 2. We're hunting for b. So I'm just going to subtract 10 from both sides. I got my equation. What was the slope again? 5, y-intercept, -13. And while I'm thinking of it, because we're going to have a quiz on Monday, there's a good way of checking your answer. Like this line right, or that point right there is on this line, so plug it in. 10 minus 13. Yep, that does equal -3. So you can kind of confirm your answer. I mean, it's not like you can know absolutely 100%, but you can feel real good about it. Okay, so same thing here. Write the slope-intercept form of the line. We're hunting for this. Slope's a half. Goes through -6 and 4. So, oops, might as well just go ahead and plug it in. Y. So y of my point's 4. Slope's a half. X is -6. Half of -6 is -3. We're going to add 3 to both sides. There's your b. So y equals 1/2 x plus 7. Okay, and then the ones we did yesterday, they gave us 2 points, so we had to use our slope formula to get the slope because they didn't just tell it to you. So second y minus the first y, second x minus the first x. All right, 2 negatives, when you divide them, make a positive. They both, 6 and 9 both divide by 3, so we're going to say the slope's 2/3. Hang on, I got to sneeze. Usually there's more than one, but not today, apparently. Okay, so I'm trying to get the slope-intercept form line. I'm hunting for this. I know the slope now. It's 2/3, and then I just need to choose one of the 2 points. Let's say I decide to choose the 3, -3. So my y, plug in my x. The 3's just cancel, leaves me 2 plus b. I'm going to subtract 2 from both sides. There's the equation of my line. Okay, so those 3 examples, nothing but review. But it's, I guess, incredibly important. So it's a good thing to review. All right, the new part for today has to do with everything from here on out. But example 4 is not new. Just telling you to do this. Definitely not new. So let's say I graph this line. We've got a y-intercept of 5. 1, 2, 3, 4, 5. We haven't graphed anything in a while. Rise of 2, run of 3. Rise of 2, run of 3. Or else I can go down 2, back 3. Okay, so there's that line. Let's graph this line. Well, those are kind of close in color. Let's get it where you can tell the difference. Let's do this one in black. Y-intercept -7. So 1, 2, 3, 4, 5, 6, 7. Rise of 2, run of 3. Rise of 2, run of 3. There's those 2 lines. What do you notice about those 2 lines? Hopefully you notice that they just run alongside each other like a set of train tracks. And they're in the same plane. They're all on this flat sheet of paper. They don't intersect. What do you call those kind of lines? You've learned about this in the past. Those are parallel lines. Come back up here. What was the same in a set of parallel lines? Because this is an example of a set of parallel lines. They had the same slope. Okay, so parallel lines have the same slope because it makes them do the same thing. Like you rise 2, run 3, rise 2, run 3. That means you're never going to be on top of something else that's rising 2, running 3 in that plane. But parallel lines never intersect, right? So it's not like you could come back and go, well, let's put a line right on top of the other one. because those would always intersect. So let's get rid of that. So they have the same slope, but different y-intercepts. Okay, because otherwise they'd be the same line. We don't want them to be the same line. All right, so if you had, say you had this picture right here, and it says, if you just looked at it real quick, you might think these are all parallel because they sort of look like they're never going to intersect. They definitely all have different y-intercepts. I don't need to worry about what the y-intercept is. But let's see which ones actually are parallel. 1, 2, 3, 4, 5. Okay, so the slope of line A, like M describes a slope, I can use a subscript to specify which one. The slope of line A, that blue one up there, is -1/5. The slope of line B is just -1/4. And the slope of line C, definitely negative again. 1, 2, 3, 4, 5. Those are the two that are parallel. So you can't really always tell by eyeballing, because if I were just to eyeball it, I'd like, B kind of looks parallel to them, but it's not. It doesn't have exactly the same slope. Eventually, it's going to keep rising far enough to run through that line somewhere down the line. Okay, but the blue one and the green one there, never going to hit. And there's a way of saying that if you want to say it shorter. Like you can say A is parallel to C. You just draw two parallel lines. You'll see it going straight up and down a lot of times when it's typewritten. But usually when people, well, I shouldn't say usually. A lot of times when people handwrite them, they slant them so it doesn't like an 11. And here's this little thing from the book. So you've got something nice and pretty in your notes. Parallel lines are lines in the same plane that never intersect. And they're only parallel if and only if they have the same slope. Okay. And then there's, again, we already said this, but they can't have the same y-intercept. Now, vertical lines don't have a slope. They have an undefined slope. So the reason the second part's there is just saying, yeah, all vertical lines are going to be parallel, which just makes sense. So this one, write the slope of any line parallel to the following lines. So what's the slope of this? -4. Parallel lines have the same slope. What's the slope of this? 3/4. Okay, now this one I can't tell by looking unless I get it into that form. So let's do that. I'm going to bring the 5x over, which makes it -5x. I'm going to go through and divide both sides by that -9. So -5 over -9 is +5/9. And then a +10 over -9, positive divided by negative is negative. And don't worry, that's just the y-intercept. Don't worry about it. What I'm looking for is the slope. Whatever the slope of this line is, the slope of any parallel line will be +2. So a lot of times you'll see people put this, the slope of something parallel, the slope of something parallel, the slope of something parallel. Okay, what's the slope of a horizontal line? 0. So the slope of anything parallel to it will be 0. This is a vertical line. What's the slope of anything parallel to it? An undefined slope. Okay. All right, but not all lines are parallel. There's another really important relationship that happens when we graph these two lines. Okay, so let's start with this one. Y-intercept of -2. You rise 2, run 5. Rise 2, run 5. Or else go down 2, back 5. Down 2, back 5. Okay, so there sits that line. Change colors. We'll do some in green. Y-intercept of 1, down 5. 1, 2, 3, 4, 5, right 2. Down 5, right 2. Or else up 5, 2, 3, 4, 5, back 2. Oops, okay. Got to run it a little crooked there. Ooh, hang on. Hey, let's see.